Well, welcome to Chapter 5, Section 2. This is on dimensional analysis, which is remarkably similar to basically multiplying fractions. So if you recall how to do that, which I'll review a little bit, you should be in really good shape. This is an important section. So in this problem, we're going to convert 45 liters to milliliters and 45 centimeters to inches. And I will give you the conversions. I don't expect you to memorize conversions, although you might have to in chemistry. And we're going to solve it using dimensional analysis. So I could give you, let's do it the way we did it last chapter. See, we're going to convert 45 liters into milliliters, right? So we have the conversion factor of 1 liter equals 1,000 milliliters. And we could do this by setting up a proportion, right? 1 liter is to 1,000 milliliters as 45 liters is to X milliliters. And then cross multiply and divide. We can get our answer that way, but this is it's a shorter and quicker way of doing it. And it's also going to help you if you have to take any chemistry or if you're nursing or any health science. So let me do this by first explaining to you that this is almost identical to fractions. And I'll explain a fraction here. See if you can get this quickly. 6 times 5 over 16. The answer is 5. Did I have to multiply the numerators and then multiply the denominators? No, I can just cancel, right? And that's what we're going to be doing, but we're going to do it for multi-step problems. Like, for example, try this one. 7 times 5 sevenths times 2 fifths. Give you a second, see if you can solve this without doing much work. And if you answered 2, you're correct. The 7s cancel, right? That's 7 over 1. The 7s cancel and the 5s cancel. And you just have 1 times 1 times 2 over 1, which is 2. So if you understand this, you're in really good shape. And this multi-step problem is what you're going to see a lot of in chemistry. And that's why we're going to use dimensional analysis. So I'm going to start with my 45 liters, and I'm going to change that into milliliters using dimensional analysis. Now essentially what I'm going to be doing is taking the 45 liters and multiplying it by 1. Okay? So we already know this is true, right? 1 liter is 1,000 milliliters. So if two numbers are equal, like these are up here, they're equal. And let's say here's two other numbers that are equal. 6 over 6. 6 equals 6. If I do that, then 6 over 6 is going to equal 1, right? All the time. Any number equal to the same number, obviously this is always going to be true. So I have these two possible ways of dealing with this. There is 1, right? And there is another way of writing. Both these numbers are 1. So I wrote it two different ways using this conversion here, right? So now I'm going to swap out this 1 with one of these two. It's either going to be behind door A or behind door B. And it's really important to choose the right one, otherwise it's just simply not going to work. Now the answer is 1,000 milliliters over 1 liter. And the reason is the liters are going to cancel. It's in the numerator here and the denominator here. So I'm canceling the liters and I'm left with milliliters. So the problem is just 45 times 1,000, which is 45,000 milliliters. By using that's dimensional analysis. Now I'm going to do it a little bit slower converting 45 centimeters into inches. First, I want to erase this board. Get me a little bit of space here. Okay, that should be enough. So when we do these problems, usually start out with what you're trying to convert and what you're trying to finish with to keep yourself straight. On a one-step problem, it's not that difficult, but we're going to go to two steps almost immediately. So here's our conversion factor. 2.54 centimeters equals 1 inch. Now with this, I have two possible ratios that are equal to 1. Because remember, this is the same as this, and any number divided by itself is 1, right? Except for 0. So I either have this or I have this. So which one would you choose? Give us some time to think about it. Put it on pause. So let's say you chose this one, which is incorrect. I just want to show you why it's incorrect. I'm going to go 45 centimeters times 2.54 centimeters over 1 inch. And I'm just going to look at the units, right? Because as you know, the units get multiplied the same as the numbers do. So if I had this problem, and if I took 45 and multiplied it by 2.54, forget about the number. I'm going to get centimeters squared over inches, right? Centimeters times centimeters over 1 times inches. And that's not the correct unit. So it's this one. And you got to be able to start seeing that, why that is. It's because the centimeters is in the denominator here, and it's in the numerator up here. So I got 1 inch divided by 2.54 centimeters. The centimeters cancel, and the problem becomes 45 divided by 2.54. Rounded to 2 decimals, I get 17.72 inches. Okay, I hope that made sense. You might want to play this a couple times just so you get the hang of it. So this is where dimensional analysis really comes in handy. I want to convert 3.5 pounds to kilograms. You want to make that change in your book. That's a typo. It should say kilograms. Using these conversions. So I don't have a direct conversion, a one-step conversion to go from pounds to kilograms. I have to use two conversions. I have to go from pounds to ounces, and then ounces to kilograms. So let's go over this. So I got 3.5 pounds, and I want to end up with kilograms. And here's my two conversions. 1 pound equals 16 ounces, and 35.32 ounces equals 1 kilogram. So hopefully you can see if we're going to change, I'm going to be multiplying by the number 1, right? Twice. So hopefully you can see you want to use this one first because it's the only one that has pounds. So the first step will be get rid of the pounds and convert to ounces. And then once I have ounces, the second step will be get rid of the ounces and convert it to kilograms. So if I want to convert this to pounds, if I want to convert the pounds to ounces, do I want the pounds in the numerator or the denominator from this conversion factor? And you need to think about that because this is the important question. If you're going to be able to do this, that's the question you need to answer. And hopefully it said, okay, well, I got to put the pounds in the denominator, because that way the pounds will cancel, right? You could always put this over 1 if you needed like a little crutch, because any number divided by 1 is itself. So this would first be 16 ounces to 1 pound. And the reason I did that, because I'm just looking at the units, these will cancel. So after I'm done multiplying 3.5 by 16 and 1 times 1, I will have converted 3.5 pounds into ounces. So I now have ounces. But now I got to go from ounces, which I want to get rid of. If I want to get rid of the ounces here, do I want the ounces in the numerator or the denominator? And hopefully it said I want them in the denominator. And you would be correct, because you want them to cancel. So this is 35.32 over 1 kilogram. So there it is. So what you're going to do on your calculator is multiply 3.5 times 16 times 1, which won't change anything, and then divide it by 35.32. And if you put that in your calculator, you should get the answer here, which I will put up. And to 2 decimal places, I get 1.59. You might want to watch this video again a couple times if you're unsure of what I did. Okay, so here is another example. You're planning a trip to France and are considering renting a car. One of your concerns is the cost of gasoline. The cost of gasoline in France is 157 euros per liter. How much is this in dollars per gallon? So I always write down what I'm starting with. So I'm starting with 157 euros per liter. And that's 1 liter, right? And in the end, I'm going to convert this to dollars per gallon. So I'm going to need 2 conversions. One is never changes, right? Liters, certain amount of liters equals 1 gallon. And we'll get that. You don't need to memorize these. And the second one is euros to dollars. And that one we're going to Google and look it up. So let's do that. So here's Google, and we're just going to go euros to dollars, and it comes right up. 1 euro is 1.21 US dollars. Right there. You can also change it around. Say you want more, $1 is how many euros. I don't know if you can quite see that, but there it is. So we got it, 1.21 US dollars. So I put in the conversion here, liters to gallons. 3.79 liters equals 1 gallon, and I put in the conversion we just found. Now this conversion, the reason we found it is because it changes all the time. Currency floats on the world currency market. And so this is changing daily. So we got the most updated one. You know, it doesn't change by a lot, but it changes. So our first thing is you can go eeny, meeny, miny, mo. You want to change euros into dollars, or do you want to change liters into gallons? I mean, there's no set way of doing it, but you've got to do one or the other, obviously. So let's say you decided to change liters into gallons. So what are you going to use for a conversion? Well, you want to get rid of the liters in the denominator, so you want to put the liters in the numerator. And that forces you to put the gallons in the denominator. So we have 3.79 liters to 1 gallon. So these will, I mean, that's a gallon. These will cancel. And as of right now I have euros per gallon, right? If I multiply, if I just look at the units, euros times nothing is euros, and nothing times gallons is gallons. So my next conversion is going to convert the euros into dollars. I obviously want the dollars up top, right? And I want the euros on the bottom because I want the euros to cancel. And I have the conversion 1.21 to 1. So now I'm just going to multiply straight across. So I'm going to get out my calculator and multiply 1.57 times 3.79 times 1.21. And on the bottom, 1 times 1 times 1 is 1. And so when I do that, I get $7.2 per gallon. Well, it's a whole lot more than we pay, isn't it? But the price of gas in Europe is very high. So this is our last example, and I'm going to, it says one medium tomato costs $2.15 and weighs a half a pound. Determine how many pounds of tomatoes you can buy for $9 using dimensional analysis. So I'm just going to write my $9 down here, and my conversion factor is $2.15 equals 1/2 pound. So I have $9, and I'm going to get rid of the dollars by placing them in the denominator. That's $2.15. And the pounds I have, I'm going to place in the numerator, 1/2 pound. So the dollars cancel, and I multiply 9 times 1/2, and then I'm going to divide that by 2.15. Place that in your calculator, and I'm going to get 2.09 watt. And your answer should be pounds, right? So here's one that's similar. It says the same thing. One medium tomato costs that. How much does it cost if you purchase 8 pounds of tomatoes? So I have 8 pounds. And I'm going to, in the end, I want to know the cost, right? So here's my conversion. And it says $2.15 weighs 1/2 pound. So I can go 2.15 over 1/2 or 1/2 over 2.15. And hopefully you realize you have pounds here in the numerator. So you want to get rid of it. They cancel, and you want dollars up here. So it's 2.15 divided by 1/2. So on your calculator, you would go 8 times 2.15. After you do that, divide that by 1/2. Or you could use the decimal 0.5. And you should get $34.40. And that's dollars, right? So to buy 8 pounds, that's what it costs. Now you could do this with a proportion, but it's simpler and quicker to do it with dimensional analysis. And the idea of dimensional analysis is this cancellation of units. So that's our last example, but I'll go over a little bit of the homework, but I think it's pretty straightforward if you understand what we've been doing. So this is a homework problem, problem number 3, which is a 2-step dimensional analysis problem. You don't have a direct conversion from liters into gallons, and that's what you want to do, but you have 2 conversions. So you're going to have to use both of these conversions. So I'm going to write this down, 15 liters, and I'm going to write down where I'm going with it. I'm going to gallons. So here's my, I want to get rid of liters right away. So I can't use this. I'm just going to confuse myself if I use this one. But I have one that has liters in it. So my first step will get rid of the liters and go to quarts. If I want to get rid of the liters, I better put it in the denominator. So I'm going to get quarts in the numerator. And I'm just going to write down this conversion first. Now I have quarts. But I don't want quarts, I want gallons. So I need to get rid of quarts. So where does it go? If you said the denominator, you would be right. And then gallons would go in the numerator. So now I'll just put in the numbers. 1 liter is 1.06 quarts, and 1 gallon is 4 quarts. So I multiply 15 times 1.06 and then divide that by 4. And the reason is because I have these ones here. They're not going to change my number by multiplication. So I want to do one more of these double conversions which have a ratio to start with, right? So use the given conversion factors here, these two, to convert 37 miles per gallon, that means 1 gallon, right, to kilometers per liter. Now in this case I have a choice. I can either convert miles to kilometers or convert gallons to liters. So whichever one you want to start with. So let's start with this one. The question you got to ask yourself, if I'm converting miles to kilometers, is where does the miles go? Which ratio? How do I make this? Do I make it 1 mile over 1.61 kilometers? Or do I make it 1 kilometer, or 1.61 kilometers over 1 mile? Which way do I make this? And hopefully you said this way because you want the miles to cancel. And that gives you kilometers in the numerator. So that's 1.61 there, and 1 there. So now I have kilometers per gallon. So I want to use this one to get rid of the gallons and get my liters. So is it 1 liter over 0.26 gallons, or is it 0.26 gallons over 1 liter? And you need to be able to answer that. And hopefully you said, well, I've got to eliminate the gallons, so they need to go on top. So the liters go on bottom. Gallons will cancel, and I'm left with kilometers per liter. And now all I have to do is multiply these 3 numbers on my calculator, because you multiply fractions straight across. And the bottom number is going to be 1. It's not going to disappear. 1 times 1 times 1 is 1. So this is problem 6 in your homework. And it says a dextrose solution contains 0.4 milligrams per milliliter. There's a conversion. Now, what a lot of students do is they don't understand that this is 0.4 milligrams per 1 milliliter. Somehow they lose the 1 there. There's a ratio, and it's got to have a number with it, right? I mean, you don't go to the gas station and say, oh my gosh, it's $2.99 and 9/10, but how much gas do you? You don't knock on the door and say, well, that's the price, but how much gas am I getting? Right? You get 1 gallon, right? $2.99 9/10 per 1 gallon. So don't make that mistake. So it says how many milligrams are contained in a 40 milliliter solution. Well, if I multiply by 40 milliliters, they're going to cancel. And so it's just 0.4, or 40 times 0.4 on your calculator, and that should give you 16, right? So it'd be 16 milligrams. Important to include the unit, 16 watt, right?